Good morning, class. Welcome to the online classes for physics of class 10th, that is electricity. In the last class, you may have seen that what was the electric field, what was the potential, what are the different components, their symbols, and in that we have seen a simple brief description for the Ohm's law. So here we are going to see what the Ohm's law is in this session. So what this Ohm's law means, that is, if we talk about a simple definition about the Ohm's law, then George Simon Ohm in 1869 he told us about this law, that whatever the potential we are providing to any circuit, right, we know that the potential means the work done to displace an electron from one point to the other. So what that means, we are trying to flow the charge, and we already have discussed that current is the rate of flow of charge. So when we are trying to flow the charge or we want to move the charge, then only the current can flow. So anything that if the current is try to flow in any the material, then it needs some work to be done on the charge to get flow. So the work done, how much the work is said to be done, that much only the current will flow. That means that much charges will flow, and that much the current will also flow. So these potential means whatever the potential is required you to move the charge, then only the current will also flow. From this relation, he told that if we take a potential difference between 2 points, that means between these 2 points, what is the work done to move that charge between the particular given 2 points, then the potential difference between that 2 points will be directly proportional to the current given by that 2 points. Means the current in that wire, in that point of wire, the current will be directly proportional to the potential, because how much the potential you are applying on any current or a circuit, that much the current will flow through that wire. That means potential is directly proportional to that of the current, and potential is given by the letter V, we already discussed, and I is the current, so V is directly proportional to I. And if you talk about the potential, this proportionality sign, I already told you that any proportionality sign can be changed into equal sign, but there comes a constant, and these constant here in this relation of Ohm's law, it is R, that is V is directly proportional to I, and this V is equals to IR, that is RI or IR. This R will come as a constant, and this constant was named as resistance. And what I told you about the resistance, that is the inherent property of any circuit or a wire that tries to oppose the flow of the current. That means it will try to oppose the flow of the charge, right? So that is resistance. So what we can write it as V is equals to IR. From there, if you want to see the value of R, then it will be R is equals to V by I. If you talk about I, then it will be V by R. If we talk about V, then it is IR. R is equals to V by I, and I is equals to V by R. These were the relations between what we can say V, I and R. So what these relations are telling us about, if this V and I are directly proportional to each other, what that means, if one value is increasing, along with that the other value will also increase. Directly proportional means that if one value increases, the other value also increases with it. That means here what you can say, that V is directly proportional to I also, and V is directly proportional to R also. That means if you are increasing the potential, the resistance is also increasing, right? So both will increase as the potential increase, but we know that current is inversely proportional to the resistance. Means if the current is very high, that means the flow of the charges is very fast according to the potential, then the current flowing through it will be high, and it will be high, then what will happen, the resistance will be low, because the object which we are using, then the resistance will be depending on that object. So that object will be having a particular amount of the resistance that can be increased or decreased by changing the potential of the battery. So when you add the battery or the cell to any circuit, then there will be some potential or the potential difference applied by that two terminals, like positive and the negative terminal of the battery. So they will provide to flow the charge, and these flowing charges will provide us the current that is given by I. So I was given as V by R, that means they are inversely proportional to the resistance and directly proportional to the potential. So when the potential is increased across the battery terminals, then the resistance will increase, but the current will also increase. But if you talk about the resistance, then resistance is inversely proportional to the current. So current is high, that means the resistance should be low. So when we talk about the good conductors of electricity, then they have the lowest resistance to that property. So resistance is a kind of resistive property that used to resist or oppose the flow of the charges or the flow of the current. Okay. Now what does resistance look like? This is what the resistor. This is a device. Resistance was the inherent property. But if you talk about this resistor component, this is what the resistor it looks like. Okay, the resistor looks like the same, and this is was the a symbol for the resistor. This resistor is shown with this like this. Okay, this is what the resistor. So resistor is a device which is used to control the amount of the current flowing through any circuit. Like if we apply one resistor or the two resistor, the current will can change, because we know that on applying the extra resistance or we are giving the high resistance, then the current flow will be less. And if we talk about the current flowing is high, then means the resistance is less. So to control the amount of the current flowing through any circuit, this component is used. So electrical component can be used by taking it in the two ways, like wire wound resistors are also coming, carbon resistors are also used to come. This is what the carbon resistor is. So this have the bands on it, you can see now. These bands, by these bands we can say that these are the carbon resistors. And the wire wound coils, if we talk about, then thin wires used to come through which we wires wounded on the wounded at on the some coils, and through that resistance can be applied on the circuits. Okay, so they are used to control the amount of the current flowing through that circuit. Okay, so what the resistance was, it was the inherent property of the current circuit or the wire. So from that, what the Ohm's law told, that voltage or the potential which we apply through the any battery or a cell, then the potential difference applied across the 2 points will be directly proportional to that of the current. So potential will increase and the current will also increase, but there comes a constant, that is resistance R, and this is for the property of opposing the current. That means they try to resist or the oppose the flow of the current, which is given as the letter capital R, and the SI unit, if you talk about, that is ohms. This is given as ohm, because ohm what Simon Ohm only give, so this is considered as ohm, and sign is given as like this, and resistance is shown with the letter sign, this one. Okay, so 1 ohm is always equals to 1 volt, and that to the 1 ampere. So that is considered as the Ohm's laws some points. Okay, so SI unit is ohm, and 1 volt upon 1 ampere now only has said. From that we have cleared that through a resistor the current flowing will be inversely proportional to it. Means if resistance increase, the current will decrease. If the resistance is decreased, then the value of the current will also increase. This means electric current will decrease with the increase in the resistor, and vice versa, what I have told. If we talk about the graph between potential difference and the electric current, then there is always a straight line. There is always a straight line only, because what we have seen that anything that if you are applying the potential to any body, if potential is increasing continuously, then there is a change in the electric current also. Like if in this condition I am having the potential of 5 volt and you are getting a 2 ampere current. Now if you are increasing it on the 10 volt, if you are increasing on the 10 volt, then the current may also increase, and it may be in the 4 ampere. Like that itself, it can increase to 15, it will change into 6 ampere. Similarly, it will continuously change. If we join these points, what we will get? We will get a straight line graph, and this straight line graph tells us that they both are directly proportional to each other. Okay, so these are some examples of the numericals related to this Ohm's law. That first question: calculate the resistance if a 5 ampere of electric current flows through a conductor having potential between the 2 points is equals to 5 ampere. What that means? Potential means V, we are talking about VA minus VB, or V, it is given as 15 volt. If we talk about the current, then I is given as 5 ampere, and it is given that calculate the resistance. I know that by the Ohm's law we already know that V is equals to IR. On putting the value of V, what it is, 15 volt, on putting the value of I, that is 5 ampere, what is the value of the resistance? So resistance will be given as 15 volt upon 5 ampere. So together if we write it as, then it is 3 ohms. Okay, see the next example, that if the potential difference between the terminals, potential difference we are talking about V only, potential difference is of 220 volt, that is across our home. So we used to get this potential difference only at the home, and an electric current of 5 ampere is flowing through it. What will be the resistance of the electric motor? So 5 ampere current is given, I and V both are given. Again V is equals to IR, that is using the Ohm's law we will get the value of R. The V value is 220 volts, and if I's value we talk about, then is 5 ampere, and the resistance is given as 220 upon 5, so that is given as 44 ohm. Okay, got it, the value of the resistance. The third example, an electric current of 15 amperes flowing through an electric fan. What is the potential difference between the two terminals? Now we are talking about potential, right? It is given as a, what if the potential between the difference two terminals of the electric fan is given as 240 volts, it is given as 15 ampere. Again V equals to IR on taking the values. V is given as 240 equals to 15 into R. So R's value will be 240 divided 15. Okay, so the answer, it will be 16 ohms. Okay, if it our fourth example, that if the resistance of an electric iron is 48 ohms and an electric current of 5 ampere is flowing through it. So current is given here 5 ampere and the resistance is given as 48 ohms. So we already know V is equals to IR. So V will be taken here, and it's not given. IR, if you're talking about, I is given as 5 and R is given as 48. On multiplying it, what we will get, then it will be 240 volt. Okay, calculate the potential difference between 2 points. That means we have to find out the value of the V. If an electric current of 10 ampere is flowing through it having resistance of 20 ohm, means resistance is already given, that's 20 ohm. If we talk about the potential difference V, it is not given because we have to find, but V is equals to IR. So V will be the same. I was given as 10 ampere. If we talk about R, that is 20 ohm. Together if we multiply, we get 200 volt. It will change into volt. This is what the format of the Ohm's law. Okay, here also the same example, that between the two terminals of electric heater, 150 ohms resistance is given, and I is given, but we know V is equals to IR. So on multiplying the values of 15 and the other 150 volt, it is given, 15 ohms and 15 ampere is given. On multiplying this 15 ampere and 15 ohm, we will get the voltage, that is a potential across the terminals, or of an electric heater we are applying the potential. So we have to find out the potential between the two terminals, that is given as 15 into 15, that is 225 volts. Okay, so this is about the Ohm's law, that is the second topic of your chapter. After this we will be seeing about the electronic components of resistance, and we will talk about resistance only, but we will see some other components also. In that resistors, we will see that how the resistors can be connected. These resistors can be connected in the two ways. One will be series and other one will be the parallel condition. So we will see how the current and the voltage will affect in this situation, that how the resistance are connected. Okay, so thank you class. In the next video we will be seeing the further topics.